going over solving related rates problems, going from easier to more difficult ones. We're starting with number 19. And problems like number 19, which is just a spherical hot air balloon being inflated. Let's see what the answer to number 19 was. 800 times 3 over 4 divided by 3 divided by 30 squared. 0.2 repeated was dr dt. 0.2 over pi. I forgot to divide by pi. 0.0707. Then in our review packet, the second kind of set of related rates problems, 5a, we should get the answer is 1 over 18 pi. Questions on that? Did we all get it? Okay, good. Mr. Wusu. You can leave pi in the answer, definitely. That's an exact answer. You can plug stuff into your calculator and give me a decimal as long as it's rounded to 3 decimal places. Okay? So good. First type of problem. Second type of problem, going back into your homework problems. It's a situation kind of like 22. Did you do 23? That was on it? Good. 23 is a good type of problem. This is like the next level of difficulty. Now, key for all these problems is to remember that we are allowed to plug in fixed values into our formula that we're using, and we're also allowed to plug in fixed relationships. A relationship like a height is 3 times a radius. Here we have a situation where sand is falling off of a conveyor onto a kind of sand pile at a rate of 10 cubic feet per minute, so that is a dV/dt. The diameter of the base of the cone is 3 times the altitude. So this and this are related. That's the height. So much that the height is equal to 3 times the diameter. Now, at what rate is the height of the pile changing when the pile is 15 feet high? So I'm trying to find dH dt when h is 15. Now, the formula for the volume of a cone-shaped thing is 1/3 pi r squared h. I will give you those formula on your quiz and on your test. So you don't have to worry about memorizing the volume of a cone. But if we look at this formula, we realize that we have r's and h's. If I took the derivative of this as I see it right now, it's going to be a complicated derivative because I'd have to use the chain rule. So I'm not going to do that yet. Instead, I need to be able to simplify it by either plugging in fixed values or fixed relationships. This relationship I will use in this formula. Ms. Quinn. Oh, yeah. Sorry. The height is 3 times the diameter? Oh, the diameter is 3 times the height. Okay. The diameter is 3 times the height. Okay? Now, let's think about what we have in this formula. We have r's and h's. Well, 2 times your r is equal to your diameter, so I get 2r is equal to 3h. Here's my relationship between r's and h's. Now, I got to think, I can either plug in h in terms of r, or r in terms of h. And I need to kind of think about that before I substitute in. And it all comes back to what I'm trying to find. Since I'm trying to find dh dt, this needs to have h's. So I will solve this for r so that I can plug in h's for r. Simplify that, I get 1/3 pi 9/4 h cubed. Maybe simplify it one more step, you get 9/12, which is 3/4 pi h cubed. After doing that, I am ready to now take the derivative with respect to t. I have a simplified equation. I just have h's and v's. Once I take the derivative, dv dt is equal to, I'll go ahead and just multiply the 3 by this 3, 9/4 pi. This will be h squared dh dt. I want to find dh dt when h is 15. 15 is a changing height. The sand pile is growing. So now I would plug in 15. And I would plug in the dv dt, which is 10, to find dh dt. Ten times 4 divided by 9 divided by 15 squared divided by pi. I get 0.006287 dh dt. Anybody else get that? Or use your calculator, or use the back of the book for that? Mr. Tabbitt.
So on our quiz, is it going to be calculator?
Calculator. Calculator quiz, calculator test. Let's talk about the test, because we're having a test next class. 16 problems. That's it. Half multiple choice, half free response. It will take you the entire hour and 30 minutes. It took me like a solid 25 minutes to do it, and I was racing through it. And that's a good gauge. If I can do mine in like 20 minutes, you can do yours in an hour and 30. So I'm thinking it's going to be a push. You will get partial credit on the free response. You will not get partial credit on the multiple choice. About half and half split. Half the questions will be implicit differentiation. Half the questions will be related rates. They will vary in difficulty from implicit differentiation, just finding the derivative, to finding the slope of the tangent, to finding where horizontal tangent locations are, to finding the second derivative. All implicit differentiation questions. In related rates, you have the simple related rates. I give you the equation. Maybe you have to turn a couple statements into information. You solve those related rates problems, to the most difficult word problem that you've seen, kind of deal, which is your inverted cone problem, I would say. Okay? So you have to be prepared for that. Just 3 lessons. All the stuff's related. Implicit differentiation, related rates, half and half. Okay. So let's do a problem just like this. Let's go to number 6 on the previous section, after the 2 levers question, and then go ahead on that 2 levers question, just skip it. You're not going to want to do that problem. So this is wheat is poured through a chute problem. This problem, wheat is poured through a chute, and then go ahead on this problem, skip this guy. Don't do that guy in general. Uses the law of cosines, it's kind of ridiculous. 5 over 8 pi, or 0.199 feet per minute. Make sure you can get that. You need a fixed relationship to be plugged in to your original volume formula. Figure out what the relationship is that you need to plug in. Once you plug it in, you will simplify this. You'll be prepared to take the derivative. Remember, we want to find how fast the height of the cone is increasing. You need dH/dt, so this needs h's.
How much did you account for?
Just remember the units, all right? I don't want to have to worry about that.
Are you going to work out the entire volume?
Yeah, but I want you to try to figure it out first. Help each other out. The key step is this. The bottom radius is half the height. Bottom radius is 1/2 the height. However, actually this is perfect. This is r in terms of h. I will plug in 1/2 h in for r to simplify my volume equation. If you can get here, you can get the rest of the way. This is what we would call a fixed relationship. Anything that's fixed, that's always true, you can plug in into your original situation.
We should simplify it as a fraction, because I simplify it and over 16 pi to pi over 8 pi into
I should give you the same thing if you simplify. Yeah, right? 2/4, same as 1/2. Now, what you need to do, Ms. Quinn, if you have 5 divided by 8 pi in your calculator, put 8 pi in parentheses. Okay, so dV dt is equal to 1/4 pi h squared dH dt. You're trying to find dH dt, you plug it in. H is 8, in for h, 64 divided by 4 times pi, dH dt is equal to dV dt, which is 10. Just a little bit of calculations from there. Okay, are we good with that one? Okay, next level of difficulty. Typically your Pythagorean theorem problems. The moving ladder, the boating problem with the fish, that was the same deal. These air traffic control problems. What do we want?
36.
36, you're not there yet. We'll get to 36. That's not Pythagorean theorem. You think it's Pythagorean theorem, but it's not. We did that problem on the video if you watched it. 27? The moving ladder problem, 28.
27, 28.
8. Why don't we do 28 because you can check the back of the book for 27. So, all Pythagorean theorem. And after we do this problem, I'm going to come up with a completely different problem with airplanes or with kites, but it's all the same. Let's get this picture out of here. All right. Construction worker pulls a 5-meter plank up the side of a building under construction by means of a rope tied to one end. Assume the opposite end of the plank follows a path perpendicular to the wall of the building. The worker pulls up the rope at a rate of 0.15 meters per second. Well, if he's pulling it up, I would say this is my dy dt. How fast is the end of the plank sliding around the ground? So the question is, what is dx dt? When x is 2.5. So dx dt when x equals 2.5. And I know the plank is 5 meters long. It's told right here. Well, notice we have a right triangle. Whenever you see a right triangle, you can draw a right triangle. You're going to use the Pythagorean theorem. Now, in the previous problem, I substituted a fixed relationship to get rid of a variable. In this problem, what can I substitute to get rid of a variable? Exactly. That plank length is fixed. It's not going to change. Since it's fixed, you can plug it in to your original equation and just deal with this. So 25 is equal to x squared plus y squared. Well, now that we have something simpler, we will take the derivative with respect to t. Giving me the derivative of 25 is 0. Derivative of 2 of x squared with respect to t is 2x dx dt. Derivative of y squared, 2y dy dt. Now, trying to find dx dt, so there it is. I need to find that. I know dy dt is 0.15. I know x is 2.5. Trying to find dx dt. Well, I'm missing one piece of information. Why? This is what makes this problem just a little bit more difficult, that they don't give you all the information that you have or you need to plug in. So what do I do to find y? Do I just leave it in there and just solve for dx dt in terms of y? No. You use the original formula and you figure out y when x is 2.5 and d is 5. So 5 squared is equal to 2.5 squared plus y squared. 5 squared minus 2.5 squared square rooted .330127. But of course, don't round until you get your final answer. So to get my final answer, I'm going to do that times 2 times 0.15. And I'll end up subtracting it to the other side. So I'd get the opposite of my answer divided by 2 times 2.5. And we get negative 0.2598, which is great. dx dt moving to the left, my dx dt should be negative 0.2598. Okay, all Pythagorean theorem. Plug in your fixed values, then you use your Pythagorean theorem to replace you're missing information. Let's go to problem number 9, the second 9 with the boy flying the kite. The second 9 with the boy flying the kite. Do this problem. The answer is 18. Make sure you know what's fixed. The kite is flying horizontally. Since it's flying horizontally, it's not going up and down. Since it's flying horizontally, the string is being pulled out to be longer and longer. All Pythagorean theorem. This 150, this is changing. But this 120, this altitude, this is fixed. Mr. Gordon. Yeah. Anybody need any help? Anybody have any questions? Are you ready to take the derivative? Once I plugged in my fixed value, I'm ready to take the derivative. D dt, both sides. I get 2d dd dt is equal to 2x dx dt. And then the derivative of 120 squared is just 0, so it goes away. Well, I'm trying to find d dt when d is 150, so I got that. 150 times 2 times d dt. However, I need to find x at this situation when y is 120 and d is 150. I know dx dt is 30. So you find x, you get 150 squared equals x squared plus 120 squared. You get x is what? 90? You plug in 90. So 2 times 90 times 30 divided by 300, and you get 18. Okay, now let's do the same type of problem, only with angles. So let's talk about something with the theta. Which one do we want to talk about? We got the fish guy, that had a theta, 45. All right. So the airplane guy, this is a good problem to do. It actually isn't that bad. The last problem. Airplane's at 5 miles. That's the altitude. That's going to be fixed. Speed of the plane is 600 miles per hour. So that's this dx dt vector. Find the rates at which the angle of elevation is changing when the angle is 30 degrees, 60 degrees, 75. Let's just do A. So the question is, what is d theta dt when theta is 30? Well, in this situation, we can actually just pick any random trig function to work with. Which I don't like about this problem, because I'd like the problem to dictate which one you want to deal with. But in this situation, it doesn't matter. So we've been used to using tangents, at least we did it for the last problem. We can use tangent here. Okay? This is going to be the formula that sticks everything together. Oops, let me not go that far yet. Tangent of theta would be equal to the y over the x, the opposite over the adjacent. Well, since I know that that is fixed, that altitude, I say the tangent of theta is equal to 5 over x. Well, I've simplified it. Let's take the derivative. Let's see what happens. I get secant squared theta d theta dt. Now, here's a big mistake made. The derivative of 5 over x is not 5 over dy dx, or dy dt, or dx dt, I mean. When we have 5 over x, that's the same as 5 times x to the negative first. You either have to use the quotient rule, or you need to rewrite to know that this derivative is negative 5 over x squared, dx dt. Quotient rule can also help you. All right, so we're trying to find d theta dt when theta is 30 degrees. I can go secant squared of 30 degrees d theta dt is equal to negative 5 over x squared. Dx dt is 600. What do I need to find? I need to find x to be able to find d theta dt. Well, let's go back to our original equation. Tangent of theta is equal to y over x. Well, I would say the tangent of 30 is equal to my fixed y over my x. So x would equal 5 over tan 30. Tangent of 30 degrees. 30 degrees is pi over 6. That's 1/2 over root 3 over 2. So that's root 3 over 3, or 1 over root 3. But then I have to square it, so bleh. Whatever. So I have secant squared 30 d theta dt is equal to negative 5 over, let me make sure I have that right, 1/2 root 3 over 2. Okay, 5 root 3. That's not bad. 5 root 3 squared. Use your calculator to get the answer. Now, if I have 30 degrees, my calculator needs to be in radian mode, from radian mode to degree mode. So let's go into degree, or you can just do pi over 6 in radian mode, whatever. I'll do 1 over cosine 30 squared. That will be divided into this stuff. I get negative 5 over 5 root 3 squared. See if I get the right answer in the back of the book. Times 600. Divided by 4/3. Negative 30. They did rats. How come it's not negative 600?
Yeah, because isn't it line basically that?
That's true. That's probably right. Probably is negative 600. So negative 30 degrees per second change that into rads. So this is degrees per second. Degrees, I need rads, so 2 pi over 360. I feel like I got the wrong answer. Three halves rads per minute.
They got 30. That's
Oh, there you go. We got degrees per whatever. It's fine. I don't know what they're doing in the back of the book. They changed the rads. I have degrees. Whatever. Okay. All right, but that's the angles. That's how you have to deal with angles. You have to use your trig equation. So in your dude, I think we need to go to our second guy. This is the first set of problems. Let's do problem number 7. Problem number 7 on the first set of problems, the rocket fired vertically. This is trig. Rocket is fired vertically. It's number 7 on the first set of related rates problems. Mr. Messer. Good, how are you? Yes. Bring it down. Yes. Thank you. Yes. Great. Thank you. Rocket fired vertically. Angle of elevation is the angle from the ground moving up. .96 rads per minute, the answer. .96 rads per minute. As long as you're consistent, I believe the answer should be the same. The key is, Mr. Tabbitt, you don't want to have to take the quotient rule of your derivative. Everybody, this is Miss Hodges, goes to UT, is going to be taking pictures of me, so don't mind her. Okay. So, Mr. Tabbitt, you don't want to take the derivative of that, right? You could, but what do you want to take the derivative of, Miss Wise? Yeah, the 4 is a fixed distance, so plug in the 4 first, and then go for it. This should be tangent of theta. Okay, so we get secant squared theta d theta dt is equal to, I'll put 1/4 dy dt. Plug in the information you know. I know that I'm trying to find d theta dt. I know dy dt is 6. I need to find theta, so that's the last thing we have to do. I'll use tangent of theta is equal to the y distance when the rocket is 3 miles high, 3/4. Tan inverse, I'll go back into rad mode. Tan inverse of 3 over 4 gives you that. That's theta. We'll do the secant of that value, 1 over cosine of the answer take that and square it. Then that'll be divided into 6 over 4. So 6 over 4 divided by that value. 0.96. Questions? I feel like everybody's getting most of the way there. It's just maybe the calculations part. Or maybe it's this part that we're getting confused about. The finding the theta part. If you ever are missing a value, you go back into your original equation to find that missing value. Okay? Next, what's up? How I'm finding theta? Okay. You got everything else besides the theta part, right? Mm-hmm. So, if you find theta, use tangent of theta is equal to y over 4. Here you get tangent of theta. We're trying to find it when the rocket is 3 miles high, so when y is 3. Tangent of theta is 3 over 4. Tan inverse both sides to solve for theta. That's the angle. Make sure you're in. Okay. Yeah, that's what I got. Okay. Yes. Yeah. So when I'm trying to find the secant of this value, secant is the same. So secant squared of this angle, 0.6435. Now I use the entire decimal, but I turned this into 1 over cosine of 0.6435, and then took that entire quantity and squared it. That's equivalent to the secant squared of that value. Mr. Tabbitt. Yep, because it's 1 over cosine squared on the left side. So you can just multiply both sides by cosine squared. Yes. Anything else? Do we want another angle problem, or do we need to move on to the light problem? Raise your hand if you want another angle problem. Raise your hand if you just don't want any more problems and you're done. Okay, great. All right. Well, let's go to the light problem. In your example problems from last class that I gave you, get out those example problems. So this packet for related rates example problems. On the back, on the top. If you don't have it, I'll write it down or I'll find it. This is the lamp problem. I'll set it up for you from your homework and you'll be able to do it. I only want you to worry about the part B to this problem, which is like what you have on your example problem packet. So, part B, dude is 6 feet tall, lamppost is 20 feet tall. Yep. He's walking towards the lamp at a rate of 5 feet per second, so that's dx dt.
Wouldn't it be -5?
Yep. -5, because he's walking towards the lamp and he's moving to the left. Question is, at what rate is this dude's shadow, length of this shadow changing? Okay? Well, we have to set up this proportion. We got our dude, we got the lamppost, we have the shadow length, and we have this x distance that the dude is from the lamp. So the dx dt is -5. That's fine. But notice what we have here. I'm not going to use the Pythagorean theorem for a problem like this. This is the only time when all you need is a proportion and you're good to go. So what you need to see is that this triangle here with the dude in a shadow is going to be a similar triangle to this triangle here with the lamp all the way to the end of the shadow. Okay, so the ratio of the height of the dude to his shadow needs to be equal to the ratio of the height of the lamp to the length from the lamp to the end of the shadow. That's x plus s. This is all you need. Because I know dx dt, well, this has x's. I'm trying to find ds dt to see how the length of the shadow is changing. I have s. I don't need a distance. I don't need this d. I don't need to worry about what this is. I don't need anything like that. I just need x's and s's, and this equation gives you x's and s's. Now what you do is you cross multiply to simplify. I get 6x plus 6s is equal to 20s. Then you could simplify a little bit by combining some like terms. I get 6x is equal to 14s. I can differentiate this with respect to t to get my answer. I know dx dt in the homework problem was -5. So 6 times -5 is equal to 14 ds dt. So that's -30 over 14. That was problem 38. 36. And it all starts with this. On the back of your example problems, do the lamppost problem with this situation. So this is from last class. I'll pull it up. Does anybody need extras? I have extras. Anybody need extras? I went over that one in the video. Yeah. If you watch the video, then you know it. But if you want to do it again, do it again. Do you need it?
So do we know how to do 36A?
You do, but it's not as important. So the key to 36A, Ms. Seifert, is you need to figure out the change in the total length. Yeah. So you need to figure out that this would be the tip of the shadow, and this would be an L, and you would try to find dl dt. Well, this is still s, and this is still x. And you'd still have your proportion. Say if this is 5 and this is 20, you'd have 5 over s is equal to 20. You only have dx dt. You have this right here. So you're not going to go 20 over L because you need to use dx dt. So you need to write L in terms of x's and s's. Well, you don't need s anymore, actually. I need to remove x, s, and I need to replace it with things in terms of L and x's. So how do I replace s with L and x? Good. And it's the same problem.
Okay.
Okay? But don't worry about that. So you're doing the lamppost problem from last class in the back.
should there be a height?
But it's cylindrical. This is conical.
Oh.
So you get 2/3 for dSdt. How do we do on that one? Yeah? You got it. Just plug in your value. So you can either say 20 over x plus s is equal to 5 over s, or the opposite. You can say this length to the height is equal to this length to this height. Doesn't matter. You would cross multiply for both of them. You would then simplify by subtracting 5s. You would then either differentiate as you see it, or maybe simplify by dividing by 5. You get dx dt is equal to 3 ds dt. You know dx dt is 2. So you plug in 2 for dx dt, solve for ds dt by dividing by 3. You have it. All right. You're a pro. Okay. Last type of problem before we take our quiz is number 17 on the second section of problems. This is the water running into a conical tank. They are telling you the hint. Now, this was like problem number 22, 24. And I told you on the notes or on the homework to look at the video to know how to do this. You need to establish a relationship between the radius of your water and the height of the water to the radius of the tank and the height of the tank. And they're telling you to do that here. So do 17. Let's see how you do. Volume of a cone is 1/3 pi r squared h. Be easier if this was 1/2, right?
Yeah.
Yeah. So you got to solve for just h, or just r.
Oh, okay.
So divide that by 10, and you'll just get r. I believe the answer is 1 over pi. Let's see. I think it is. Yeah. 0.318. How'd you do? Okay. So all it is the radius to the height is equal to this radius over this height. Good. Yeah. Left and right. Okay, question. Mr. Gordon. Because it's a fixed relationship that will always be true. Right? We're allowed to plug in fixed values. We're also allowed to plug in fixed relationships. The ratio of the radius to the height will always be that ratio 5 to 10. Okay, the radius will always be a half of the height, no matter what. Now the key, and they don't tell you this, is that since you need to find DHDT, you need H's. So since you need H's, you solve for R so that you can plug in H's, so you get 1/3 pi, and then you plug in 1/2 H squared times H. Or H over 2 squared times H. That simplifies to be 1/12 pi H cubed. Take the derivative of this to find DHDT. That's the hardest type of problem. Okay? But they gave you a hint. I'm not going to give you a hint like this on your quiz or your test. You're going to have to say, oh, I need to use a relationship to plug in for R for H.
So basically, all problems that are going to be like this, you're going to have to find a relationship between.
Yes. Because you won't have enough information given to you to be able to plug in after you take the derivative using the product rule. Okay? That's it. Here's your quiz. Quick quiz. Pass up your homework. Just went over problems. I think you'll be fine. Don't worry. Don't worry.
Can I stay right there?
Trust me. It's all going to make sense in the end. All going to make sense in the end. It's all going to make sense. Don't worry. All going to make sense. I just want you to work through it. Go ahead. Don't worry. You don't trust me enough. Just trust me. Trust me.